have a reaction here. Mole of hydrogen gas reacting with a mole of bromine gas in an equilibrium setting to yield 2 moles of hydrobromic acid. They're all gases. In fact, I'm kind of lazy and I'm not going to write G there. The question asks us then, tells us that the equilibrium concentration constant is 1.9 times 10 to the 19th. It then asks us to determine what the equilibrium constant is with respect to pressure. So once again, Kc is the equilibrium constant with respect to concentration, molarity, and Kp is the equilibrium constant with respect to pressure. We can do that because all of these reactants and this product are gases here. If they weren't gases, you couldn't do this. As I outlined earlier, Kp, there exists an equation that says that Kp is equal to Kc multiplied by RT raised to the delta N. So we have Kc. We have to use a proper value of R, which is going to be 0.08206 liter atmospheres per mole Kelvin, at least the R that I like. The temperature, it tells us, is 25 degrees Celsius. We, of course, have to convert that to kelvins in order to have my T here have the same units as the kelvins here in the denominator of my ideal gas constant. So I'm going to add 273.15, and I'll get 298.15 kelvins as my temperature. I've got now T, I've got R, but what is delta N? Well, delta N is the change in the number of gas moles as you go from the left to the right. So we have to count up how many gas moles there are on the right side of the equation and how many total gas moles there are on the left side of the equation once the equation has been balanced. So if you look at all the gas moles on the right, there are 2 of them. If you count up all of the gas moles on the left, there's 1 gas mole of H2, 1 gas mole of Br2. So there's 2 gas moles on the left. So you take the number of gas moles on the right, you subtract from it the number of gas moles on the left, which is 2 minus 2 equals 0. So now all we have to do is substitute the numbers. I've got Kc right here. I've got R, which is right here. I've got temperature, which is here. And I've got delta N. Well, delta N is 0. Beautiful thing about that is that when you use that as an exponent, it reduces all of this to 1. So really Kp ends up equaling, well, it ends up equaling Kc.